Can you tell us about the research you're conducting and projects you're funding to combat antibiotic resistance?
Well, we're part of a government-wide effort to identify and respond to the critical issue of antimicrobial resistance. So as the National Institute of Allergy and Infectious Diseases, our mandate is to do the basic and clinical research to lead to not only an understanding of the mechanisms of resistance, but also to be an important component of the pipeline of the development of new antibiotics. So when you look at antibiotic resistance, there are multiple ways to address it. One is to identify it, prevent it by public health measures that were just mentioned by the use of antibiotics, including in animals. And then another very important component is to develop point-of-care diagnostics, as well as what we don't usually appreciate is to really understand at the molecular level the basis of the evolution of antimicrobial resistance. So one of the things that at the NIH has been doing in the era of genomics is we have the capability of very rapidly sequencing an entire quasi-species of bacteria that evolve and pinpoint on that bacteria or virus what the precise mechanism of the resistance is and to develop targets for that. Another thing that we do at NIH that's important now, because one of the things that I believe are inhibiting our ability to have a robust pipeline of antibiotics to take the place of those that are no longer useful when you develop resistance, is to collaborate with the pharmaceutical company. So in general, when the pharmaceutical company wants to make a product that's going to be a blockbuster product, they'll do everything themselves. They'll do the basic research, the preclinical, the clinical, the development, and the production. When you have something like antibiotics, antibiotics in general are not a blockbuster item. New lipid-lowering agents, new Viagras, new antihypertensives are blockbusters because millions and millions of people use them almost every day, whereas antibiotics are used in spurts, 7-day course, 10-day course. Not a lot of people use them. So what we've had to do, and I think this is one of the most important things that we do at NIH, is that we partner with the pharmaceutical companies and do what I call de-risking the process. So rather than just doing the fundamental basic research and maybe the early phase 1 and preclinical trials, we're now pushing the process all the way to the point where we make it less risky for a pharmaceutical company to participate in the production. So it's fundamental basic research, it's the development of diagnostics, it's understanding the genomics, and it's major partnering with the pharmaceutical corporations. And we spend a significant amount. Our budget for antimicrobial resistance alone is about $420 million a year, which is actually doubled from just about 8 or 9 years ago.
Wow.